So I propose I start. My name is Roy Brouwer. I'm Executive Director of the Water Institute, organizing the Value of Water in Canada webinar series. I counted briefly, and I think this is the 25th webinar since we started in 2022. We're very delighted to have a Waterloo alum to speak to us today about the value of water related to the water data and National Hydrometric Program. Before I introduce the speaker, I would like to acknowledge that I participate today on traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, the land granted to the Six Nations that includes 6 miles on each side of the Grand River, as you can see on this map. University of Waterloo and the Water Institute is committed to the truth and reconciliation, calls to action, and implements those across our campuses through research, learning, teaching, and community building. Before I introduce the speaker, the main housekeeping rule is that we'll have a approximately 30 minutes presentation, and then followed by Q&A. If you have questions for the speaker today, please use the Q&A box to enter your questions, and we'll get to these questions at the end of the presentation. Don't use the chat, please. Only the Q&A box for the questions. So as mentioned, we have a University of Waterloo alum today. It's Dr. Wayne Jenkinson. He's the Executive Director of the National Hydrological Service within Environment and Climate Change Canada. The NHS includes 340 staff people and is the federal administrator of the National Hydrometric Monitoring Network, and is responsible for operating more than 2,000 water monitoring stations on rivers and lakes across Canada. Before joining the NHS in 2021, Dr. Jenkinson spent 5 years as the Senior Engineering Advisor at the Canadian section of the International Joint Commission, directing studies and board activities relating to water level management, water quality, and numerical modeling activities in transboundary region. Prior to his time at the IJC, he was the Senior Research Engineer and Water Resources Lead for the Ocean, Coastal, and River Engineering portfolio at the National Research Council of Canada. Dr. Jenkinson is the Hydrological Advisor to Canada's permanent representative to the World Meteorological Organization, is past president of the Canadian Society of Hydrological Sciences, and has received his master's degree from the University of British Columbia, and has mentioned his PhD from the University of Waterloo in civil and environmental engineering. We're very happy to have you with us today, Wayne. I'm happy to hand over the floor to you.
Thanks, Roy. Thank you very much. I'll begin by sharing my screen so I can show my presentation to all of you. I'll just get confirmation, Roy, that that's happened effectively.
It worked. Thanks.
Great. Thank you so much. So it's a pleasure to be here today. Thank you, Roy, for the introduction and for inviting me to speak with you and your colleagues today. Again, my name is Wayne Jenkinson, Executive Director of the NHS, or the National Hydrological Service. We'll be talking a little bit today about water data in Canada, particularly surface water data, and really how my group at NHS tries to provide that data to Canadians for their benefit. I'm sure many of you will be aware of us. I hope many of you will. We are known by a few names. We run the National Hydrometric Program, as Roy mentioned. You know, the Water Survey of Canada, if you like, as we've been known, is part of my organization. I'm sure you're using the data that we produce for many of your studies, analyses, feeding your models, et cetera, whether you're with an agency or an academic. I like to tell my staff that, we at the NHS are the backbone of hydrology in Canada. Without the data that we produce as the authoritative source of surface water data, it's very hard to do hydrological studies. It's also, we're sort of like the oxygen in the room when it comes to hydrology in Canada. It's sometimes people take the data for granted, but if the data goes missing, you suddenly notice it like you would if you no longer had any oxygen to breathe. So this talk today is going to be a little bit about what we do, how we see ourselves and the value we bring to Canadians and our close partners in the provinces and territories. But the question that we're asking ourselves now is the value that data brings, not the value of the water, but the value of the water data. This is a question that we've engaged Roy and his team to help us understand, and we'll paint the picture a little bit for you in terms of what that looks like for the NHS. So I will try my best to advance the slides here. Great. So This will be our discussion this afternoon. We'll provide a little bit of a background on water data needs in the Canadian context, just to set the stage in the world that we operate in. A bit about us, the National Hydrological Service. We swim, if you like, in that context and try to deliver data. So we'll explain to you what we do exactly and how we do it. We have quite a few challenges that maybe aren't fully understood in how we deliver these data to yourselves and to other Canadians. So we'll walk through a few of those important challenges that we're facing and some of them that are getting worse. As I mentioned, we're trying to understand the value of data, water data in Canada. Part of that is taking a close look at some use cases to sort of establish that framework for that value. Not a quantification, if you like, but at least making those linkages. There are important opportunities that we're taking to improve ourselves, which I'll share with you. And then finally, the last steps that we're about to undertake in partnership with our friends at the University of Waterloo to understand water data value in Canada a bit better. And then we'll take your questions. So water data needs in the Canadian context. To open the discussion, I think it's important for us to understand the challenges that we are facing now in this new global reality of climate change. We recognize that the challenges that we're facing with a changing climate are severe and increasing. I've got a list here at the bottom of a really short timeline, last 4 or 5 years or so, and you can see that there are a substantial number of events that have affected us greatly. The Peace River flooding in 2020. We'll remember the heat wave and the atmospheric river that happened in BC in 2021. Record-breaking flooding in the Winnipeg River. You'll remember Hurricane Fiona in the Atlantic provinces, both in 2022. And last year was famous for the record-breaking droughts and wildfire season that we were all suffering through. So the demand for data to help us understand and respond to these sorts of events is growing day by day. So we recognize that it's important for us to strengthen our services to provide the data and prediction services so that we can manage these types of changes more effectively, whether it's dealing with floods, long-term response to droughts, or even just managing our water resources on a day-to-day basis in this new context. So this is sort of the larger challenge that we're facing as citizens and as a community. So we do have some intrinsic water challenges that I think are important to go over so that we can fully understand I guess how NHS can even exist in a country like Canada. Those are some jurisdictional challenges, how we've organized ourselves legislatively within the country itself, some geographic challenges and some climate challenges. So jurisdictionally, this is a bit important to articulate. Some formative legislation, the Constitution Act 1867, and then the Natural Resources Act of 1930, really devolved the responsibilities for managing water resources to the provincial and territorial governments, effectively stating that water is their responsibility. A former colleague of mine has said that when water's in the air, it's a federal responsibility. As soon as it hits the ground, it's a provincial responsibility. So how we could have a national hydrometric program in the context of those two sets of legislation is a question. And the answer to that question is really the Canada Water Act. So the Canada Water Act, which was, I believe, signed in 1970, allows for the federal government, among other things, to set up agreements with provinces and territories to cooperate in the management of water resources or anything really water related. So it's through that act that we can set up partnerships with the provinces and territories to deliver on a coordinated data system for Canada. There are other instruments that are important. The Department of Environment Act is important as well in setting up federal responsibilities and dealing with water in the environment. We have other treaties and agreements that are in place around the boundary that complicate or in some ways, facilitate the management of water in those regions. The Boundary Waters Treaty of 1909 is one, but we have many other international treaties that require us to, or must be considered, I guess, as we manage water resources. They could be the Columbia Water Treaty, which is, or the Columbia River Treaty, which is under negotiation, or the Souris River Apportionment Treaties. And then finally, I'll just say this as a point of note that a lack of Indigenous representation in these legislative instruments is pretty much ubiquitous, and this is something that is actively being addressed or is trying to be addressed, at least in terms of the Canada Water Act going forward. So that's the framework legislatively that we're playing in, and we'll see how that that drives the NHS going forward. The geographic challenges, I'm sure we all understand. Not only are we an extraordinarily large country for our population size, but really the geographic variability remains a challenge. So not only the size, but the variability. The issues we're facing on the prairies are not like the issues we're facing in BC or the North or Central Canada or the Atlantic. So managing water data collection in such a varied region or very variable country makes it really challenging. We have very many remote unpopulated regions. Most of our population centers are near the south. The north is quite distant. So that getting to these places is a challenge. And finally, our water resources are extensive. So monitoring and managing these is a challenge in and of itself, I think, just considering the vastness of it. And then finally, just talking about climate change challenges. I think many of us would know this. Canada's warming at twice the global rate. Our Arctic is 3 times that rate. That's the estimate right now, and that the events that we're trying to deal with, like those I showed in the previous slide, are extraordinarily costly, and something that not only makes it challenging or adds urgency to the data collection that we're providing, but also makes that data collection itself more challenging. So we'll talk a little bit about that in subsequent slides. So we are in the water data business. If you're in a water data business or any business, you need to know what the needs are and who your clients are. We conducted a study with our partners to sort of get a high level, if you like, desk study to understand exactly what was needed of our clients. For the National Hydrometric Program, the basics are there. They want to see the level and flow data. So it goes without saying, perhaps, plus the metadata that describes how that data was collected and its quality. But also there's a lot of variable requests for the types of data and how that's collected. Real-time data is important for flow forecasting. Daily and long-term historical data are critical for long-term analyses, climate change analysis, looking at any sort of flooding studies. Short-term and seasonal flow predictions are in high demand. Some provinces can do this work themselves, others cannot. And the analysis is another data product. So not only the data itself, but the accompanying statistics, associated trends, and specific calculations like natural flow calculations, which articulate or provide estimates of flow with the abstractions from anthropogenic influences removed. We're not the same as our atmospheric counterparts when it comes to clients. So our atmospheric friends do, the famous Environment Canada weather predictions. Every Canadian probably is aware of the weather over the next few days with the apps in their phones. Our client segments are a bit different. They're a bit more on the practical side, on the user side, because the nature of the data is quite different. Our clients include governments, land and resource groups, transportation, insurance industry, recreation and tourism, culture and academia. This is something that the provinces and territories together with us came up with to sort of identify who it is that are our primary users. It's not comprehensive, something that we need to dig more into, but you get a sense of the types of users that are actively using our data to deliver on their own responsibilities, whether they're land and resource extraction, hydro production, provinces and territories, or Indigenous communities. They have specific needs that they come to us for. So this is largely our context. Now we'll talk a bit about the NHS and how it tries to provide a valuable service within the context that I've provided. So the NHS, the National Hydrological Service, we're a division within Environment and Climate Change Canada. We're part of the Meteorological Service of Canada. So, the prediction services are just down the hall from me here in Ottawa. So we work with them quite closely on some things, but we are really the body within MSC that deals with all things related to water. You may be familiar with the Water Survey of Canada as a name. That is basically the operational arm within the National Hydrological Service. It is the federal lead on the National Hydrometric Program, which we'll discuss. Again, as Roy mentioned, we have roughly 3,000 hydrometric stations. My group operates 80% of those. We provide real-time as well as archived data. It's an old group. The WSC was established about 115 or 16 years ago, and we're ISO certified. This represents probably 60% of the work that the NHS does, that my group does. The other 30% or 40% or so is related to Hydrological Services. So this is an expert group that provides various services so that the federal government can deliver on its federal mandates related to hydrology, hydraulics, water resources engineering. So this is supporting boundary water services, impact assessments, oil sands monitoring, flood mapping, supporting the government generally in a number of areas. So these are the two business lines, if you like. Today, we're just going to talk about some of the details on the Water Survey of Canada and the National Hydrometric Program and how this data is produced and the value that it brings, or that we think it brings to Canadians. So this is your National Hydrometric Program. The map on the right is a relatively current map of the number of hydrometrics, or the location of the hydrometric stations across the country. So we are, the National Hydrometric Program, the authoritative source for water surface water quantity data in Canada. So as I mentioned before, managing water is a provincial and territorial responsibility as per the Constitution Act and the Natural Resource Transfer Agreements. But because of the Canada Water Act, we're allowed to, or directed to, set up an arrangement with the provinces and territories, multilateral partnerships, to build this National Hydrometric Program collaboratively. What we end up with is a fully cost-shared program where we have contributions from all the provinces and territories, as well as the federal government, to deliver water data for Canadians. We have the colors on that map that you see on the right indicate the class of stations. So some of the stations are federal, some provincial, some shared. Federal means that that station is delivering primarily on federal responsibilities. Provincial is likewise shared. It's deemed that that station has joint contribution to mandate for both the province and the federal government. Those dictate how the costs are shared. This is a success story. It's been around for almost 50 years. Next year will be a 50-year anniversary. Most of the agreements were signed around 1975. We were the Inland Waters Directorate back then. A lot has changed in Canada in terms of the governance of water. But the NHP, the National Hydrometric Program, has remained since that time. So it's extraordinarily successful, extraordinarily useful, and a really an amazing example of cooperation between the provinces and the territories on such an important file. So some details about us. How much water do we actually produce? You will know this probably as water experts, but we have real-time data dissemination and archive data dissemination within Water Office. You see the address there. 2,200 of our stations, the one that we operate, have real-time dissemination. The others do lag because they're operated by other groups. We probably produce 1.2 million data points or more daily that get uploaded to the site. And we have traffic in the order of 500,000 to 1 million visitors to the site every month. It doesn't seem like a lot, but it's important to recognize that we have API type systems where data can be automatically pulled from the website to drive models and other systems that our provinces and territorial partners use. So that doesn't capture the full nature of our traffic, but all this to say, we're well set up for data distribution, and we have a very active operational program that pushes data out to Canadians for their use at a pretty rapid rate these days. So I spoke a bit about our client segmentation report. That was a desktop exercise. We also have ways that data is provided to our clients in a bit of more interactive way. If the data that they're finding on the website isn't sufficient for their needs, or they have questions, they can submit requests to us and we will try and answer those specific data need requests. They're called National Inquiry Response Team requests, or NIRT. But it's an interesting picture into who is asking for data from us, right? They're categorized by industry sector. And we have the chart from 2023 on the right and a table showing 3 years of data on the left. As you can see, that it's a lot of requests for special data needs coming from consulting services. Sort of the preponderance of them are provincial and territorial governments. Our partners also make requests. But after that, we have energy companies, usually hydro, individuals, academia, some federal governments, all making individual requests. So it's a spectrum of needs and a spectrum of clients. I will say that excluded from these are some of our closest partners in hydro companies. They sometimes submit hundreds of real-time requests a year to us for a response, and they aren't necessarily included in these calculations. So they're relatively low in the list, but they are very demanding in terms of the water they need for their hydro operations. So this is a measure of who's using our data. And this is an important question as well. Where are we missing water data? So it's easy to say we're a national program, but to what degree do we cover the country? It goes without saying, perhaps, that the NHP network is not uniform across the country. We have more stations in some areas, mostly in the south, than others. The study was conducted by Paulin Coulibaly, many of you will know him, from in 2013, which was looking at how our network compares to the WMO, World Meteorological Organization standard that was published in 2008 in terms of hydrometric density recommendations. His results were pretty stark. I think 12% of Canada's area meets that guideline. 50% is poorly gauged, roughly, and 40% is basically ungauged. We did a subsequent study to look at how that network compares against key risk themes or areas of investigation that we wanted to look at. Those included the network's ability to assess climate change impacts on Indigenous communities, support for populated areas, natural resource economies, and cryosphere monitoring. The map on the bottom right shows areas where we are not, or we're at risk of not meeting those obligations. In short, the northern regions and the remote regions of this country tend to be underserved, or there is risk of insufficient coverage. No province or territory is immune to this. And really, it's only the populated areas in the natural resource economies that are being reasonably well served by the network, and the other areas are a bit at higher risk. So yeah, we do have missing areas for hydrometric data monitoring. Sorry about this. And just as before I leave the discussion of the National Hydrometric Program, just a few numbers to share with you, just for your own reference. We do produce a report. That picture on the right is of our annual report from 22-23. These numbers are from there. Again, 3,000 stations, 600 of those are run by our partners, mostly Quebec and Saskatchewan, but others as well. As I said, roughly 340 staff, many classifications types. We need a lot of expertise to drive this program, and 26 offices across the country to service this. So we are definitely a national program. And it's about $46 million a year to run this program, and it's almost a perfect 50-50 split in terms of cost sharing between the federal and the provincial and territorial contributions. So really is a great example of cooperation. So understanding water collection challenges. So I think it's important for sometimes, maybe not this group, but other groups might take for granted the data that's being provided by the NHS for their use, maybe not fully understanding the challenges that we have to go through to get that data properly QA'd and disseminated to you. I wanted to underline a few of these challenges because I think it speaks to the value that this work brings to the data that's being used. So I'll go through a couple examples to give you an idea of the challenges that we're facing these days, with specific examples. So this is the Calgary flood of 2013. Long recovery. So basically, this is to say that we have severe flooding events require sustained elevated efforts from our team to support data delivery. So during the events, certainly getting out there, making sure that data is continuing to be delivered, that the flow is being properly estimated, and that the stations are still functioning. But after these large events, it can be years for us to recover fully. So the Red Deer River on the bottom, you can see that was a cableway, was blown away by the Calgary flood that we had to rebuild. The rivers themselves can change course, requiring us to rebuild the stage discharge curves, and that can take years. For this particular flood, it took us about 10 years, I think only really last year, that we really were fully recovered from the impact of that flood. This is different from other monitoring networks that can recover quite quickly. From a hydrological point of view, it can take quite some time for us to get back to full strength after these events. So the long recovery is a real challenge. I want to talk a little bit about the changing hydrological patterns that we see across the landscape. This is a plot of the Okanagan River in 2018 on the right. The 2018 numbers flows are in 2018, or in yellow rather. You can see the percentiles there in different colors. We're seeing that patterns are shifting. We're seeing, in general, more rapid snowmelts. We're seeing persistent wet periods outside of the freshet, and we're also seeing very extended dry periods that are occurring across the country, really. This all adds to real complexity. This is a graph I like to show because we see the flooding early in the year. This is some news reports in the Okanagan Basin. Osoyoos was flooding at that time, near record flows. But then after 3 months, we had almost no precipitation in that region. We had almost record lows when we got to the end of the summer. And then we had forest fires and other challenges. So if you look at the flow over that whole year and average it out, it might be an average flow year, but it's nothing close to an average year. and the extra effort required to deal with data collection during these really high flows and these low flows dealing with forest fires, and low flows have their own challenges, makes for an extremely challenging period to work with. So it's something that's happening more and more, not just here, but all over Canada, and with something we're reckoning with. Changing winters are a real challenge for us too. Historically, we've had a number of stations that we call seasonal, which basically means that once winter comes, we shut them down and we don't visit them again until just before the freshet. Mostly because they were frozen solid or their flows would be extraordinarily low. A changing climate, milder winters has changed that for us. You know, we have warm periods where flow starts again, maybe in the middle of February. And in order for us to really characterize what's happening at these stations, we really should be going out and getting those data. We aren't really budgeted to do that. So do we change all the stations to annual and collect that data at increased cost? What are the consequences if we don't do that? So our partners are asking those questions, and we ourselves are asking those questions. And it's another stressor. These changes are another stressor for us in terms of how we manage this data collection. I threw in a picture of the Ottawa River. That's where I'm calling you from. It's from Ottawa. Of course, the canal didn't open last year. It's just another example of how these winters are changing in Canada. And the last one I'll share with you, and this is a relatively recent one in terms of how we try to respond to the needs of our clients getting water data to people, is the Chilcotin River landslide of this summer. You may have seen in the news, July 2024, massive landslide in the Chilcotin River Valley, was a kilometer long down the length of the river, 600 meters wide and 30 meters deep. It effectively became a dam holding the river back, creating a lake that was rising at about a foot an hour. So BC identified this as a risk. Obviously, if there was a breach, it could be extraordinary. They needed more data to really monitor it and assess that risk. So we flew out, put up some temporary stations, started collecting data within shortly after 24 hours, I believe, and pumping that data to the BC Forecast Center and to our water office. So with that data, they were forecasting a discharge of roughly 80 times the normal freshet flow. That was the BC Forecast Center. But because we had the data, they were able to characterize the breach, evacuate, prepare for the flood wave, and the breach finally occurred 5 days later. And you didn't hear much about it, I don't think, because it wasn't as much of an incident as it might have been. So again, these unprecedented events, they require rapid response from us. We're going to places that are otherwise engaged to provide data to support emergency response. This is not entirely new, but certainly more frequent for us. So these are the challenges that we're trying to deal with. So you understand the NHS now, you understand how we try to overcome some of the challenges we've got in the Canadian context. As I mentioned before, what we're trying to solve with Roy and his team is to really figure out what the quantified value is of the data that we're providing to Canadians. These are some case studies that we're going through to sort of articulate where the value resides, if not quantified. So it's more of a qualified, if you like, identification of value. But these are important, I think, to sort of show who's using our data and how that's being used to support others in their programs. So the first one I'll mention, and I think there's 4 of them here, and this is very important, and one that's been recognized, is that the support for flood mapping activities within the country with a changing climate, and the fact that very few or lots of high-risk areas are not fully characterized in terms of flood mapping within the country. The importance of our data is critical. Long record hydrometric data to assess that flood risk, to use that data to drive flood models, so that we can characterize the flooding risk, the flooding hazard, as well as the possible effects of climate change and anthropogenic inputs. There's a project underway now being led by Public Safety, and we are contributing to it. It's the Flood Hazard Identification Mapping Program. This supports the PTs to complete flood maps in high-risk areas in Canada. So it is underway and continues to deliver. We do provide science and engineering advice, but the data that we provide too from the National Hydrometric Program is critical for the analysis that gets done as part of this exercise. So this is an example of value. What would the value of that data be? What would the risk, what would the cost be if that data wasn't available? These are questions that we have yet to answer. Naturally, our data is extremely important for flow forecasters in the country. The provincial and territorial governments are responsible for this, but we can provide the data so that they can have the real-time flow to provide the best forecast models they possibly can. Many of the provinces have forecasting centers and rely on our data to provide early warnings. Some regions don't have forecasting capabilities, but still use our data to provide real-time information to warn the public and drive alerts. Hydro companies in particular are very active users of this data for this purpose to maximize their hydropower generation. Companies like Hydro-Quebec and BC Hydro are actively connected to us to make sure that they get the best data possible to maximize their power production and profits. Support for drought characterization. Again, provinces and territories and the federal government have responsibilities for estimation of floods, or of droughts rather, the timing and severity. Streamflow data does get employed to help characterize those droughts. So we've been in the midst of a multi-year hydrologic drought across the prairies. Here's a picture of the Oldman River Dam in December of 2023. BC and Alberta both use this data when they release their severity indices and other warnings about drought and water usage in their regions. So again, important data. What's the value of this data for these provinces? As they deal with things like controlling irrigation and managing their water use in a period of scarcity. And finally, in terms of support, transboundary water sharing agreements. This is my old métier. We have many international and provincial transboundary water apportionment agreements. They rely on timely and accurate data from us to ensure that there is compliance with the agreements that are in place, so that the right people, the right groups are getting the water that they're entitled to. So domestically, we support groups like the Prairie Provinces Water Board. They have an agreement in place that dictates water sharing between Alberta, Saskatchewan, and Manitoba. 70 stations are committed to providing this data for this purpose. So this data makes sure that the water that's being shared from Alberta to Saskatchewan, eventually to Manitoba, is done in an equitable way. Similarly, the work that we do with the International Joint Commission helps us identify how we share water with Americans to ensure that we're compliant with the orders the IGC has put in place. Two examples of the St. Mary and Milk Rivers and the Souris River. These are critical, and without the data that we have available, makes it impossible to be compliant with these agreements. So here's some opportunities for improvement. Just to get a sense that we're not sitting on our laurels, or we're not ossified or stagnant in the work that we're doing. We see certain ways to address some of the challenges that I've already articulated here through the program. So I'll go through these quickly to give you an idea of what we're looking at to be better at our jobs. We've been actively involved in innovation in hydrometric technology for a number of years. We think and we know that there are ways for us to provide more automated, reliable, remote ways for collecting and validating hydrometric data in the context of a changing climate. Sometimes with these major storms, we can't get to the stations either in time, or we can't get into the river to take measurements. So some of these tools that we're developing in partnership with our American friends, academia, and others will help us be more effective at getting this data without expending any additional resources. There's a long list here, but they're basically optimizations, new technologies, new approaches that we're testing, field testing, to try and incorporate into our hydrometric program. Our goal really is quite simple. We want to make sure that we improve data collection and add value to the program, and maximizing the resources we have available to provide that service. We've been involved more recently in hydro prediction within the Environment and Climate Change Canada family. There are extensive prediction capabilities here. They provide all of us with our weather prediction services that we all know and love. Work has been done to expand that prediction services to have more, they call it, ecosystem, or ecosystem modeling approach, which basically allows us to leverage these high performance computers to provide estimates of flow prediction across the country. Although provinces are responsible for delivering those forecasts, these tools can help us augment those forecasts, or provide forecasting tools for those provinces that don't have access or the capabilities or the resources to do them themselves. We work very closely with the provinces and territories to deliver this. There's a community of practice that directs this work. The goal really is to make sure that we have flow prediction estimates for the PTs, provinces and territories, for forecasting, but also for us to use as nowcast estimates, so that we can have estimates of flow even in locations where we don't have gauges. So there's not trying to replace our hydrometry, but it can be a supplemental data source to help us understand what's happening in areas where we don't have gauges, and we can't have them everywhere. Quickly on space-based Earth observation, we're a large country. It's impossible to be everywhere, but there are a couple of missions that are quite interesting to us. The Surface Water and Ocean Topography mission is launched now, the SWOT mission. It should provide some estimates of water levels that we can use. We're participating in the calibration validation exercise now to see if these data coming down from the satellite can be used and translated into water levels and flows in a reliable way. It's still a science mission, but we're hopeful if the results are good, that it might end up being operational at some point and something we can use to augment the work that we're already doing. The terrestrial snowmass mission, this isn't been launched, it's in the planning phases now, but this mission provides some hope that we might have a better characterization of snow water equivalent on the ground using space-based Earth observations to provide that. Target launch, that's not correct anymore. It's going to be 2032 at the earliest. But again, the goal here is to try and leverage other satellite SBEO tools to get a better handle on water resources in Canada. So we're active on these missions to sort of supplement the work that we're already doing. And finally, and importantly, Indigenous partnerships and collaboration. So we know that, and I mentioned earlier, that Indigenous participation historically has been lacking. We don't see much mention of them in these acts, treaties, and agreements that have been in place historically. But there are new initiatives within the government of Canada and elsewhere to improve that relationship and improve that engagement. Canada Water Agency, being newly formed, is charged with reviewing the Canada Water Act to include Indigenous rights in it. So these are beacons for change. Within the NHS, we've been actively engaging with Indigenous communities in lots of different ways, but I think a coordinated approach is still lacking. But it's getting stronger. And I think we've been given direction to sort of build those relationships more effectively and look at co-management and co-governance models, not only in hydrometry, but in water management efforts. There have been some successful studies looking at Indigenous knowledge. There was a study that was done at the IJC with NHS support to look at Western knowledge alongside Indigenous knowledge to really look at the timing of fish spawning in rivers. And interesting results, really, to know some of the signals that the Indigenous communities use to know when the sturgeon are spawning are almost as useful as the Western tools. So lots of work to do there and lots of collaboration opportunities. So just checking the time, this is great. Next steps to understanding water data value in Canada. So I think we've characterized what the NHS is. We understand that I'm trying to get a better handle on the value of the water data that we produce for Canadians and our partners. We understand the challenges and the value that work might bring to the data that people use. And we see what might be coming down the pike in terms of next steps for us to improve our hydrometric data provision for Canadians. The last step here is the step that we're trying to take with Roy and his team to have a more quantified, objective understanding of the value of the data that we produce. Not just understanding the use cases, but really understanding the value that those data bring and what they wouldn't bring if they weren't there. So what we do understand, we think, is the product we produce, the effort required to deliver that product, some of the challenges, who our clients and users are largely, the needs largely, the use cases to a large extent, and the opportunities for improvement. So this is what we understand, and this is fine and useful. But what we don't have a handle on yet, and this is what the study that we're doing with the University of Waterloo is going to help us understand, is can we objectively determine the value of water data for Canada? So I would like to have an answer for you for this, but we don't yet. The study's starting, and we'll know more shortly, I think. But this is what we were building to, and this is where we're at launching off point, if you like. So this is the socioeconomic value study that we're working on basically right away. The objective, and hopefully we can I was talking to Roy, maybe we can come back here and once we have some answers, share them with the team, with the group here. But to quantify the economic value of the information provided by our network and the development of the economic valuation methods to be certain about that value. So this is what Roy and his team are hoping to provide for us. Hopefully you guys aren't seeing that. So we develop project plans in partnership with some of our provincial and territorial partners, BC and Nova Scotia, but Professor Roy Brewer and his team are helping us execute this. This is a new area of investigation. So Roy and some of us have looked around for others that have tried to do this work. We haven't found many examples of it. So I think Roy and his team are breaking new ground here as we try to really get a handle on what that that value story, or really a quantification of that value would be. So this first phase that's going to take us to March is really to identify some important benefits and develop methodologies to quantify those benefits, really, and have a handful or some number of them really sorted out and available for sharing by the end of March, if that's possible. We just launched this summer. We got the contract in place very recently. The first phase is to be completed in March 2024. But the goal is really to get us on our way and to, I guess, provide leadership like Waterloo often does in understanding this particular water challenge. So, and that, I think, is the last slide. So I'll leave it there, Roy, and we can maybe work our way through some questions.
Great. Thank you, Wayne. And we feel no pressure after your last comments to deliver what you're asking us to do, which is quite a challenge. Thank you for this enlightening presentation. We have a number of questions in the Q&A box that I'll read out loud for Wayne, and then he can try to answer. So the first one was from an anonymous attendee, and I wasn't completely sure what the question was, but I think the anonymous attendee is asking whether there are specific grant programs that water resources companies can apply to.
Interesting.
You identified some potential crisis type situations this type of for-profit incorporated business may work to alleviate.
Interesting. Yeah, I'm not sure about so we do have a grants and contributions arrangements, and they are in support of some of our programs. So we have, I mentioned the innovation that we're doing. We have a grants and contributions component to that innovation. There are grants and contributions component to the flood hazard identification mapping project, and there's grants and contributions to the prediction project that I identified as well. So they are available. I know that they have been awarded to primarily academics. They have been awarded to some nonprofits. I know the CWRA has been awarded some grants and contributions, for example. I don't know of I think there have been, I don't know if we have been, or there may have been some private companies that have received grants and contributions as well in this context. So I believe that's possible. I don't know if, was that the rest of the question, Roy? I'm not sure if there was more to it, but
I think that was it. So yeah, I think that was it.
Yeah.
I'm not sure if this is the same person, but it's another anonymous attendee. He says that he or she says that our business has a disaster response and preparedness capable water source type technology product. Can we monitor data to observe where our systems are or will be needed?
Oh, interesting. Yeah, I think, can they monitor data? I mean, certainly they can. I think it's an interesting question. I think if you were dealing with disaster response, you'd probably want to connect with your provincial, territorial representatives to understand how that might integrate with what they would do as part of disaster response. In terms of data collection, of course, you can collect any data you want. If you wanted to feed with it into the National Hydrometric Program, be part of our community, then that would require some discussions with myself and our group to know how you would be a contributor of data to the program. It's a bit complicated. We have pretty high standards, but that's certainly the case. If you're needing data from us, then you can certainly make requests to the NERT system, and we'll provide that data for you. So there's a few intersection points there, I think, for that particular user to get an understanding of how that water data might support their product, or vice versa.
Good. Braden McNeil is asking, and now it just escaped me. Most flow forecasting programs seem to be currently operated by provincial governments. Are there any plans to launch a national or federal flow forecasting program to support provinces or communities that do not have dedicated programs?
Yeah, so this is a good question, and I breezed over it a bit in the presentation. So one has to be a bit careful. The federal government has to be a little bit careful when issuing forecasts, because it really is the mandate of the provinces to issue those forecasts and issue those warnings. So we have to be careful not to step on their toes, if you like, to issue conflicting forecasts or just otherwise interfere with what their obligations are. So, and some of the provinces are quite adamant about that. They don't want to see us issue forecasts at all to the public when they are issuing their own. However, there are other provinces that are quite interested in seeing our raw products, evaluating them, and possibly just sending them out directly. So our intent is to have prediction services across the whole country. at a skill level that is going to be useful by the provinces and territories across the whole country. Some provinces that have already forecasting systems might ingest the data. It could be state variables on snow, it could be runoff, it could be anything, and to improve their own forecast capabilities. Others may use them directly. Will Environment Canada be issuing flow forecasts like they do weather forecasts? Likely not, considering our mandated responsibilities don't extend to that. But we are here to help and try to provide as much information as we can to lift everyone up to a level of capability that will provide maximum benefit to Canadians and reduce risk to Canadians. So
good. Caroline Hillsmith is asking, environmental consultants use hydrological models calibrated with average flow data for stormwater design, yet with a wildly changing flow due to climate change impacts. How do municipalities and provinces develop sites practically?
Yeah, so if this is interesting. So yeah, the climate, it's tricky, right? So if you're developing models for stormwater design, which is really looking at what the flood impacts might be once your storm designs are in place, how does that get done? Are you using the appropriate methods? This is part of the work that's being done under the Flood Hazard Identification and Mapping Program, the FIMP program. That document I showed, there was a document that was on one of my slides that shows standardized procedures for doing this and incorporating climate change into flood estimation techniques and how you would use them in your model. So there are standardized approaches that are being published as part of this program, and ECCC, my group, is contributing to those. So I think how we address climate change and the tools that you can use, are that challenge, given that we're such a fractured country jurisdictionally, providing national leadership on what our approaches could be to basically handle that climate change challenge for environmental consultants that are trying to develop these tools is important. So my recommendation would be to investigate the Flood Hazard Identification Mapping Program website, look at some of the advice that's coming from those guidelines documents, and see if it provides value for you, because it may give you some direction on how to integrate climate change into your analyses. So,
thank you. I'm going to jump to Cynthia McLean. She says, thank you for acknowledging in the introduction that today's talk focused on surface water data. What near-term opportunities exist for inclusion of groundwater, Canada's largest freshwater resource, in national freshwater monitoring?
Yeah, it's a good question. So I think, it's one of those examples of how, mandates are specified for particular groups, and we are ossified to a degree, and hopefully that will change. Our mandate is really for surface water. We know groundwater is important. I don't think I've been to a conference in the last 2 years and someone hasn't asked me this question about what about groundwater. It's something we're actively discussing. You'll note the Canada Water Agency is holding workshops to get feedback from data users on what a good data strategy might be and how I presume groundwater will fit into that strategy. I agree with you. I think that there needs to be a more coherent approach to including groundwater. It's so valuable. I don't know what the path forward is, but I think it's a recognized need. And I think the federal government will start taking action, at least to sort of better characterize that need. I would say keep raising this. And if you have an opportunity to connect with the Canada Water Agency in any capacity on this, make sure you raise that concern, because it should be a part of their strategy as they develop it. So.
Great. Yeah. So Braden McNeil is seconding Cynthia's comment and also commenting that it especially contributes so significantly to base flow during periods of drought.
It's extraordinarily important. I think, and I think we have a pretty good data collection dissemination system that people find quite valuable. That's what we're trying to solve, Roy, I think, is that value question. But certainly the groundwater is critical, especially in some regions, like the work that we're doing in the prairies now. Without it, it really is hard to get a good handle on sourcing water in a river, really. So.
Yeah. I'm going to go back to an anonymous attendee. She or he is asking, how is NHS connecting flow data to other monitoring and surveillance needs like water quality impact assessments or ecosystem flows?
Yeah, ecoflows, that's a good question. So I think this is not dissimilar to the question on groundwater. So again, we have, there's a science and technology branch of Environment Canada is responsible for environmental water quality sampling, I guess. We're surface water quality, there's surface water quantity or or quantity, their quality. Certainly our data is being used for eco flows or for e-flow analysis, and it can be. The DFO is one of our clients, and they use our data regularly. So I think our data intersects a lot of those needs. But one thing that maybe what your anonymous person is identifying is that integration is probably something that could be improved. Again, not dissimilar to the groundwater question, and that more coordination amongst these various data providers would probably yield overall benefits to data users going forward. So,
yeah, thank you. Taylor Johnston is asking, is the NHP socioeconomic value of water project looking for private partnership engagement?
it's a good, I don't know. I think maybe ask us, maybe when we come back in April or something, where we can see what we've been able to accomplish. I don't know how to answer that question exactly, because I don't think we know what we will find yet. So that may remain to be seen. But come to the next talk, maybe, Taylor, and we can see if there's more to say.
Yeah, because what I understand is that when you were talking about your customer segments, you're not charging a user fee, are you?
No. We have an open data policy, and really that's something that we want to try and maintain in terms of the provision of these data. So, but can the private sector help us in some capacity in understanding value? I'm not sure even how to frame that question yet, but we might know more, I think, in the coming months after we've taken a closer look at this project. So,
yeah, thank you. So Kathleen Cameron is asking if the documents mentioned during your presentation will be shared, or the links to documents can be shared with the participants.
Yeah, I think they can be. Some of them I think are internal. I don't know if they've been fully released for public consumption, but most of them will be. So maybe I'll try and connect back with you and Julie and see if we can provide links to this group.
That sounds good. So if there are others than Kathleen Cameron interested in the documents that Wayne was referring to, please reach out to me or Julie Grant, who's hidden behind the Water Institute logo. And then once we hear back from Wayne, we can share those documents with you.
Yeah.
I may not have told you this in the beginning, but there will be a recording posted on the website of this talk as well. So if you're interested in hearing or trying to even find maybe some of these documents on your own, just look at the recording again afterwards.
Great.
Taylor has another question. Taylor Johnston, would water value formulations be linked to use case usefulness value?
I think so, right? I mean, the discussions that we've had, Roy, that those use cases are largely driving. We figured we may need different formulations for each use case because some of them are so different, right? That the benefits that would be accrued from a hydropower production organization could be quite different from those, doing irrigation in the prairies, for instance, or flood hazard mapping. So hard to say, but I think there would be some strong links for most of them. The Venn diagram does intersect, but that's certainly that's our early thinking, I think is fair to say, Roy. So
yeah. So we identified a couple of challenges when it comes to identifying what the user value is. One is the causal relationship between the information that's being provided and the decision that's been made afterwards based on the information that's been provided. And then the other one is maybe obvious, a credible counterfactual. Without the data and information, what would the decision or what would the user have done without the available data and information?
And maybe I'll say too that I put Roy extraordinarily on the spot here in terms of the work that we're going to do, but it is investigative. We're not sure what we'll find yet. So, but we're hopeful there'll be some utility at the end of this. So,
yeah, we'll try to program something in the spring term, maybe once we've had some.
Let's see what our results
initial results are. Yeah, happy to do that. Great. I don't see any more questions. We're 5 minutes to the hour. So a great moment to finish, and thank Wayne once again for his presentation and also taking the time to answer the questions that you all had. Thank you all for joining us for this first webinar of the new fall term. We're looking forward to see you again in a month's time. So the next talk will be on October 16th by Derek Davey. He's the CEO of Econs Water Technologies, and he's going to tell us how he's going to fix water during his talk on Wednesday, October 16th. Thank you all for joining. Thank you, Wayne, for your presentation, and thank you, Julie, for the production in the background. Thank you all for being with us this afternoon. Have a great rest of the day, and looking forward to see you again in a month's time.
Thanks, everyone.
Thank you, everyone. Many thanks, Wayne.